All right. Good morning, everyone. Welcome to the May Water Conditions Monitoring Committee. My name is Emily Adrid, and I am with the Colorado Water Conservation Board. Today, we will have presentations from the Colorado Climate Center, NRCS, and a guest speaker, Jeff Deems from the Airborne Snow Observatories. So, I have no announcements. Other than it looks like Allie will be presenting from the Colorado Climate Center, and this will be her first presentation with us. So welcome, Allie, and I will kick it over to you now.
Great. Thank you, Emily. I will go ahead and share my screen. Okay, can you see this okay?
Yes.
Awesome. Yeah, good morning, everyone. My name is Allie Mazurek. I recently joined the Colorado Climate Center back in January. So this is my first time giving the WCMC talk. Any feedback or criticism is definitely welcome. And if I miss anything huge along the way, please definitely let me know. So with that, we'll go ahead and get started. So first we're going to take a look at the past water year, so the first 7 months so far. We'll be looking at temperature, precipitation. Here's just a cool image of the tornado that happened near Denver the other day. Really picturesque, and I think you could see it from pretty far away, so that was pretty cool. Okay, so taking a look at our first 7 months of the water year, so October through April. Essentially every single month for these first 7 months has been above average. These first 7 months are tied for our 10th warmest on record. So aside from January, it's been much warmer than average. And that includes April, which I'll get into more of in a little bit. So this graphic here is just showing the average temperature rank for those first 7 months. And you can see here that the warmth has been pretty widespread across the state, particularly across the western slope and southern Colorado. And then taking a look at just the past 3 months, so February through April, you can again see that western Colorado really stands out here. Statewide, this was the 12th warmest on record. Sorry, that text below the figure is incorrect. But yeah, so it has been quite warm since for the start of spring. And then taking a look at precipitation. So this is the past 7 months, again, for our start of the water year. If you can recall, November was quite wet here, the fifth wettest on average, but aside from that, we've either been close to average or below average. You can still kind of see that November snowstorm standing out across the eastern plains. And then you can see that across the western slope and southwestern Colorado that it's been quite dry for the beginning of our water year. And if we take out that November snowstorm, so just looking at December through April, so the last 5 months, you can see that kind of that above average precipitation signal across eastern Colorado has largely disappeared. Statewide, this has been our fourth driest December through April period on record. That's relative to 1901 to 2000. So yeah, particularly again across the western slope, it has been very dry there, but much of the state has been experiencing lower than normal precipitation. And then here I'm showing the quadrant charts that we often show at these meetings. So if you can find the star here, I'm not sure if you can see my cursor, hopefully you can. Over here, kind of on the top left corner, you can see that for our water year, we've been running warmer and drier than average. And I have that relative to the 30-year baseline, which you can see from that light gray line there, and then a 100-year baseline. So either way you slice it, it has been drier and warmer than average. And then taking a look at the last 3 months, kind of a similar story here. Definitely notably warmer and drier than average. The last 3 months kind of stand out even more so than the signal on our water year, because we kind of had a cool January and a wet November. So that sort of tamped down the signal there a bit. And then taking a look just at April, so we can see here that we were um, we were warm, we were drier than average, but only a little bit warmer than average. And I'll show a plot for that later. So definitively drier, but a little slightly warmer than average, but not to an insane extent. Okay, so next we're gonna look into April a little bit more closely. Here's just another shot of that tornado that happened east of Denver on Sunday. This was actually captured by a CDOT camera, which is kind of crazy. So yeah, we'll talk about that a little bit more in depth, and then we'll also talk about what May has looked like so far. All right, so this plot here on the left is showing average temperature rank for April 2025. So you can see by the red colors here. And again, this is relative to 1901 to present, so about a 130-year period, or sorry, 1895 to 2025. So you can kind of see here that we are warmer than average. Not too only slightly warmer than average, but kind of some places that sort of stand out are kind of the northern Larimer County areas and Weld County, as well as parts of the Eastern Plains that you can see over here. And then the West Slope, again, has been warmer than average, as well as parts of the San Juan area. However, this plot is a little bit masking kind of what happened in April. So we had some pretty extreme temperature swings during the month of April, and I'll kind of go in a little bit more depth about that here in a couple of slides. And then taking a look at the same thing, but for precipitation, again, our April was, while it was slightly warmer than average, it was definitely drier than average. So kind of some places that stand out the most are sort of east of Denver here, as well as the northern part of the state, and again, the West Slope. And notably, this has been our 7th straight drier than average April. So April is typically a pretty wet month in terms of snowfall, particularly across eastern Colorado. But lately it has definitely been drier than average. Okay, so taking a look at now moving into May. So this is our May precipitation through, I believe this is, yeah, Monday morning, the 19th. So yesterday at 6 a.m. If you live in Eastern Colorado, you may have gotten some thunderstorms on Sunday. This offered some beneficial precipitation to parts of the eastern part of the state, but kind of the more substantial precipitation event that we had happened earlier in the month, kind of around May 5th through 7th timeframe. And that's really where some of these bigger totals across the Sangre de Cristos and the Front Range area sort of came in. We had a pretty good snowstorm there, and then also beneficial rainfall across the I-25 corridor and parts of southeastern Colorado. And kind of zooming in just over the past week, as I mentioned, we had storms across northeastern Colorado on Sunday that brought some beneficial rainfall to the northeastern part of the state, as well as parts of the Front Range Mountains. So you can see from the precipitation totals here, we kind of got a little over an inch in some areas, but it's worth noting that this part of the state typically sees precipitation on the order of 2.5 to 3 inches during the month of May. And as I'll show in the next slide or two, we're still running below average for this time of year in lots of these places. And then we also saw some precipitation across the western slope. But the drought has kind of been most significant there, and it was not really enough to be drought busting, which we'll get into drought here soon. Okay, so this is showing the month to date percent of average precipitation through the 19th, so yesterday. So you can see here that the precipitation across the southern part of the state has been running above average for May. And again, that's thanks to the rain and snow event that we got earlier in the month. And then you can see here that despite the precipitation that we got on Sunday from some of those heavier rainstorms associated with the thunderstorms, we're still kind of running behind average for May across much of northeastern Colorado. The Front Range and Urban Corridor has kind of lucked out and gotten some steady rain on a couple occasions, as well as some heavier embedded thunderstorms. So they're not doing too bad. But again, on the western slope, despite some precipitation that we got over the weekend, still running below average. And just as a reminder, May is typically the wettest month for much of northeastern Colorado. So if you look on this figure on the left, this is showing the month of normal maximum precipitation. So these dark green areas here are areas that typically May is their wettest month. And so across northeastern Colorado and eastern Colorado as a whole, late spring to summer precipitation is really important to their water budgets. And that is also kind of captured here in this figure here, which is showing the proportion of average precipitation that we get in the month of May. So these kind of teal colors are places that typically get a disproportionate amount of their annual precipitation during the month of May. So yeah, so we still have a little bit of May left, and hopefully we'll make up some more of those deficits in the northeastern part of the state. But just kind of wanted to point that out that this is typically when we should be expecting most of our rainfall to occur here. And then taking a look at May temperatures. So this is through May 19th. And we kind of have sort of a dichotomy happening here where the northern part of the state has been running above average in terms of temperature for the month of May, where the southern part of the state has been cooler than average. And I think that is probably in large part, again, due to that winter storm that we had across the southern part of the state earlier this month. So now flipping back briefly to April. So I mentioned earlier that April was slightly above average in terms of temperatures, but that was kind of accompanied by some pretty major temperature swings. So I'll start with this figure up here on the right. This is just showing Fort Collins's daily maximum and daily minimum temperature for the month of April. So you can see here kind of mid-month, we had temperatures climb into the mid 80s. We set a bunch of records during that kind of warm spell, which you can see here's a plot showing some of the daily high maximum temperatures that were set, specifically on April 13th. So yeah, climbed into the mid 80s across the urban corridor here. And then in southeastern Colorado, we got even hotter. Many places got into the mid 90s. So this was a pretty substantial heat event for mid-April. And then soon after that, it was followed by a snow event. And this is just a picture from a CDOT camera showing that snowfall on I-70. But we also got some snow across the Front Range during that particular event. So that's pretty uncommon. We don't typically climb that warm and then get snow. Usually it gets that warm and then stays warm. So that was kind of something notable that we had during April. And then another significant event that I've been touching on throughout this presentation so far is the spring rain and snow that we got in early May. So this plot here on the left is just showing snowfall reports from CoCoRaHS, the Community Collaborative Rain, Hail, and Snow Network. So this one here is just showing snowfall reports in the foothills west of Denver. So you can see several instances of totals exceeding a foot here, but lots of others kind of in the greater than 6-inch range. So that was a pretty substantial late spring snow event there. And then the Sangre de Cristos also got some really beneficial snowfall. We have sort of generally fewer reports there, but several places reporting greater than a foot of snow. And then further south into New Mexico, I saw one report of like 3 feet of snow. So kind of a crazy late spring snow event, particularly for our southern mountains. And then this figure up here on the upper right is just showing the 48-hour precipitation totals from that event. So again, notably, the Sangre de Cristos got some really beneficial snowfall. Some places saw more snowfall during that event than they did throughout the entire winter. So that was really great for them. And then southeastern Colorado also got a lot of beneficial rainfall from this event as well, which you could kind of see in the earlier figures, as noted by that above average precipitation signal for the month of May that we've been seeing. And here's just a fun picture from Pikes Peak. They were sort of in the epicenter of some of this heavier precipitation from that event. So they too got quite a bit of snowfall. And then lastly, the third kind of major event that we've seen over the last month or so were these spring storms. So we're kind of entering into our severe weather season here, particularly in eastern Colorado. So kind of two notable events we had, first starting on May 14th. So this was a pretty substantial wind event for eastern and northeastern Colorado. This was actually the second most number of wind reports recorded for a single day in Colorado. So a wind report is any report greater than 58 miles per hour. So this was the second most that we have on record, second only to the June 2020 derecho, which was, if you can recall that, a very damaging event in parts of Colorado. And so this event also included two significant severe gusts, which are gusts greater than 75 miles per hour out in Phillips County. And here's just a picture from Holyoke from those thunderstorms. I saw some pictures on social media and it seemed that they got some pretty major tree damage in town there. And then, of course, on Sunday, we also had another severe storm event. There was that tornado or multiple tornadoes that occurred kind of east of Denver that were pretty well documented. And then some scattered hail and wind reports further east in the state as well. Okay, so now we're going to move into drought. So here is the most recent drought monitor that was released Thursday morning. So this is data through last Tuesday. So again, before that precipitation that we got over the weekend. And I'll just zoom in on Colorado here. So over the last month, conditions over Western Colorado have deteriorated in terms of drought. We sort of saw this introduction of this new area of D3 or extreme drought on the western slope. We've also seen drought starting to degradations across northeastern Colorado, and then things kind of across the central part of the state have relatively stayed the same. And then we've seen we started to see degradations in southeastern Colorado, and then those sort of started to improve. So here's just another way of showing that. So this is the 6-week change in drought monitor class. And this is since the beginning of April through the most recent drought monitor released last week. So again, you can see things are getting worse for the western slope, to no surprise, based on the lack of precipitation that we've been seeing there. The Sangre de Cristos did see some improvements from that snowstorm that we got in early May. And then things are starting to not look so great in northeastern Colorado. especially given the lack of precipitation that we've been seeing during a time that's supposed to be one of their wettest months of the year. So that is definitely something that we're paying attention to. And here's just showing the class change since the beginning of the water year, so October through now. And again, you can see here that the western slope really stands out on this map as drought conditions have definitely deteriorated there, as well as across south central Colorado. Meanwhile, kind of across the Front Range here, we have seen some improvements thanks to kind of some steady, lighter precipitation events that we've seen scattered throughout the water year. And then things are, again, getting worse for northeastern Colorado. Okay, taking a look at soil moisture here. So right now, the soil moisture conditions are not looking very good across western Colorado. That's true both for the 10 centimeter depth as well as the deeper soils, so 1 meter depth. And then in northeastern Colorado, we've definitely seen things starting to dry out here. And then southeastern Colorado has kind of rebounded a little bit where they were seeing some drying soils, but that May precipitation kind of helped out there a little bit. But if we're just looking at the last week, so these are new plots that Russ recently added to our drought page on our website. So these are just showing 7-day changes in soil moisture, the 10 centimeter depth on the left and then the 1 meter depth on the right. So kind of drying out almost everywhere in the state, except for the mountains, which we think is probably most likely due to the snow melt starting to happen there. But yeah, elsewhere in the state, drying out. And then here's just another way of looking at soil moisture. So this is terrestrial water storage percentiles, and kind of a similar story here. Worse conditions kind of across the western slope and northeastern Colorado. So this is accounting for not only soil moisture, but also groundwater and snowpack as well. So kind of a similarly not great story for those areas. All right, so last thing here is we'll get into kind of what we're looking at for the next month and then into the summer as well. So just taking a look first at our 7-day precipitation forecast. This actually looks slightly better than the one that I looked at yesterday. But still, if you look at the color bar here, these are mostly meager precipitation amounts. And these look to be mostly kind of occurring in the form of hit or miss afternoon thunderstorms, not really any sort of widespread big precipitation event expected in the next 7 days, at least of right now. So that's not great in terms of our drought expectations. And then here's kind of another way of looking at that, which is showing how much this 7-day precipitation forecast departs from what we would expect from average. So even though we are expected to see precipitation across eastern Colorado, this is still running below average, again, because this is one of our wettest times of year here. And then, of course, across the west slope, little to no precipitation expected there. So that's also running below average. And then here's just kind of another way of looking at that a little bit more closely. So kind of the greatest likelihood of when we might expect these thunderstorms are sort of starting on Friday, and then through the weekend into early next week. So before then, still looking pretty dry here. And then taking a look at temperature over the next about 15 days. So I have here, this is the GEFS, or the American Model Ensemble temperatures. So these gray lines here are the average maximum and minimum temperatures for this time of year. Denver plot on the left and then Grand Junction on the right. And you can see here, temperatures are expected to kind of climb for eastern Colorado through the end of the week, and then potential cool down sort of early next week. And then perhaps getting above average as we head into June. and not too different of a story for Grand Junction as well. So somewhat soon, we should probably be expecting our first 90-degree day for Denver and Grand Junction, which is not too off from normal. That's typically expected in late May to early June. So um, not too concerning. And then taking a look at our 8 to 14 day temperature and precipitation outlooks from NOAA's Climate Prediction Center, looking at potentially above average temperatures, particularly for Western Colorado, and then the potential for above average precipitation as well. But I'm not super convinced by this, and I think that there's quite a bit of uncertainty in the models, which I will show briefly here in a minute. And then taking a look kind of further out, so June through August, our seasonal temperature and precipitation outlooks, looking pretty likely to be above average in terms of temperatures, and a little bit of uncertainty in terms of precipitation. Many parts of the state are kind of showing equal chances of above, below, or normal precipitation. So that sort of scenario is a bit more muddy, but definitely greater confidence in above average temperatures throughout the summer. And then just getting back to precipitation really quick. So looking at, these are the percent of ensemble members that are showing on the left below average precipitation, in the center near average precipitation, and then on the right above average precipitation. And this is the European ensemble model. So you can see here, very high likelihood that we'll be seeing below average precipitation over the next 15 days. So that's kind of running a bit counter to what the CPC is saying. So yeah, we'll kind of see how that shakes out. I think kind of some of the uncertainty from that. So again, this is the European model. And then if I go to the next page, this is the American ensemble model. It looks like they are suggesting some chance of above average precipitation, kind of especially in southern Colorado. So I think that's sort of where some of that uncertainty in the CPC outlook is coming from. So yeah, we'll sort of see how that shakes out. Hopeful for rain for sure. And then this is my last slide here. So just taking a look at our ENSO projections. So if you recall, we were in La Nina, kind of a weak La Nina during the winter, and then now we have officially shifted to neutral conditions. And those are expected to persist through the summer, but we do see the potential for La Nina to redevelop as we head into the late summer and early fall. The blue lines here are La Nina, and then the gray are neutral conditions. So pretty much equal chances of seeing either of those as we head into the fall. Yeah, so kind of just to finish up here, April was warmer and drier than average. The first 7 months of our water year were also among the top 10 warmest that we've seen on record. And outside of that major precipitation snowstorm that we saw in November, things have been pretty below average in terms of precipitation since then. May has been running above average in temperatures in northern Colorado, below average in the southern part of the state, and then sort of the reverse for precipitation, above average in southern Colorado, and below average in the northern part of the state, as well as the western slope. We have our neutral ENSO conditions happening right now, again, with the possible redevelopment of La Nina in the fall. And then our seasonal outlook is suggesting above average temperatures in the summer, and possibly normal or below average precipitation, but there's a lot less confidence there. And I think we could kind of see any of those things. Yeah, so with that, I will stop. And if we have time for questions or if anyone has discussion, happy to hear it.
Great. Thank you, Allie. I do have one question, just based on some of the last few slides that you showed about the precipitation in the next couple weeks. Do you know if the NOAA's Climate Prediction Center includes both the American and the European models? They do? Okay.
Yeah, they do.
Okay.
Yeah.
Gotcha.
Yeah.
Okay. Any other questions for Allie? All right, well, hearing none, if something pops up in your head, feel free to write it in the chat. But thanks again, Allie. That was great. And I will pass it over to Brian now.
Thanks, Emily. Good morning, everyone. Get my presentation shared here. All right, can you all, oh, wait, no, I gotta share my screen. Forgive me. And go into slideshow mode. All right, now can you see my presentation?
Yes.
Perfect. All right, thanks.
Yep.
Got a number of slides here. Gonna try and get through them pretty quickly. So I'm just gonna go ahead and get started. So as of this morning, snowpack is 58% of median. The majority of this presentation I put together 5 days ago on Thursday, and numbers were a little bit different. I'll go over kind of what's changed a little bit. But when I was putting most of these slides together, it was on Thursday, the 16th, and snowpack at that point was 51% of normal. We did receive about a half inch, a little bit more than a half inch of precip over the last 5 days. Didn't really amount to much in the ways of snowpack, as you can see indicated by the black line here. But in terms of precipitation, it did help out a little bit, but it just kind of stagnated snowpack as opposed to it really improved it, which is great. We'll take a slowdown of melt of snowpack at this point, just to kind of help it out a little bit. And as I mentioned, snowpack went from 51% of median to 58% of median over the last 5 days. So a little bit of improvement, but nothing really to write home about. And a lot of these AWS plots, air, water, and soil is what AWS stands for. It's all the tool that we use to generate these plots. I try to include naturally this year, last year, because it sits in our minds relatively fresh. And then I put one more year that's relatively close to where we're at this year. Forgive me one sec. So that similar year kind of floats a little bit. In some years, it's 2022, 2021, and 2018. It could be other years as well, but just keep an eye out for that. It's just, again, something to compare closely to this year. Okay, so I'm going to roll back to Water and Climate Monitoring Committee presentations ago. We'll go back to March 24th. Statewide snowpack at that point was 93% of median. And as I think we all know, if you've been living in Colorado for a while, we kind of have trends where snowpack is sometimes better in the northern half of the state and not as good in the southern half of the state. Can be flipped, but over the last few years, we've seen a general trend where snowpack is worse in the southern half of the state and better in the northern half. So going back into March, snowpack was near normal in the northern half of the state and below normal in the southern half of the state. Fast forward 1 month to the last meeting we had, snowpack degraded relatively quickly. It was a warm April, as Ali pointed out. And the southern half of the states saw an increased or saw a decrease in snowpack, a much more speedy decrease in snowpack than even the northern half of the state, but the northern half did see a decrease as well. Snowpack declined statewide to 70% of median on April 22nd. And then now to this month, this map was generated on the morning of the 16th. In this case, we labeled it as end of day, but snowpack as of the morning of the 16th was 51% of median. However, the little text box I filled in here indicates that it was 58% of median as of this morning. Nonetheless, the map does still show what the general trends are. Even as of today, snowpack is worse in the southern half of the state, and only the higher elevations are really holding on to snow at this point. But even that snow is below normal. And in the northern half of the state, you can see the vast majority of the sites are below normal snowpack, and just barely holding on to some of that snow, but it is melting off relatively quickly, with the exception of these last 5 days. These last 5 days did, as I mentioned earlier, hold on to snowpack just because of the precipitation that we received and some of the slightly cooler temperatures. Going into a higher resolution view of the major basins, I always like to dive into the sub-basins within the major basins just to kind of have a look at, what snowpack looks like. Again, southern half of the state showing little snow or just a little bit of snow at the higher elevations kind of hanging on. And then in the northern half of the state, which is relatively normal because it is a bit higher elevation and it's further north, does tend to hold on to the snow a little bit longer, but all indicating below normal snowpack. So one of the more important metrics that we like to look at is the snowpack peak. Usual snowpack peak is early April for the basins in the southern, or the mountains in the southern half of the state, and then late April for the northern half of the state is where snowpack usually peaks out. And the next slide will get further into dates, but for this particular slide here, wanted to show where the individual sites peaked out as a percent of median peak snowpack. So you can see in the southern half of the state, snowpack was just peaked out well below normal. You can see in the Rio Grande Basin, a number of sites barely made 50% of their median snowpack values, so well below normal. And that snowpack peak is usually about the maximum amount of volume from the snowpack that we're going to see running off. Now there are storms that come and add on to that snowpack later, but the majority of the snowpack in a given year has built up and is usually summed up for the most part in that snowpack peak. And that's why why I like to use it as an indicator of what runoff we should see. So in the northern half of the state, snowpack peaked about 100% of median, a little bit below that actually, and statewide it was only about 81% of the median peak, so semi-significantly below normal, particularly in the southern half of the state. I also like to look, as I was mentioning earlier, at the date of the snowpack peak, and I know this is a little bit small, so forgive me, but it is a valuable graphic because it shows how early or late the snowpack peaked at each site across the state. So you can see the vast majority of the sites in Colorado peaked earlier than normal. On average, it was about 11 days earlier than normal this year. There are a handful of sites that peaked a little bit later. That's well within the norm. But it is valuable to know that the snowpack peaked when it peaked, because that also has an impact on how efficient the runoff will be. Now, if we were to wind up getting above normal precipitation during the melt period, well, yes, of course, that would boost stream flows and help the stream flow last longer. But as Ali kind of pointed out at the end of her presentation, it looks like things could dry out a little bit. And if that were to happen, the below normal snowpack peak as well as the early snowpack peak, and thus the early melt of snow, would probably lead to drier streams at an earlier date than normal. And I'll get into some of those snow to flow graphs and stream flows here in a little bit. Okay, I'm going to try and speed up. I'm running a little bit behind. So I'm going to go through a number of the basin time series graphs for snowpack and just kind of indicate where, again, this year's snowpack peaked with respect to median and how the melt is progressing. So looking at the South Platte Basin, you can see we actually peaked near about normal along the median line, but we did not peak near about the median snowpack peak. If I won't get into it right now, but if you have questions about that, they are two different metrics. It's just the way the statistics and the numbers are done, but there is definitely significance there. So you can see that snowpack peaked out a good bit earlier than normal here. Snowpack did try to sustain for a while, but it the temperatures were just a little bit too warm, even in the South Platte, and did start to melt off a bit early, a few weeks early. Moving into the Colorado headwaters here again, snowpack peak was a little bit below normal, but still better than it was in the southern half of the state. And then as we work our way down into the southern basins of the state, you can see the Gunnison peaked above the 10th percentile, but below the 30 percentile for snowpack trends. Excuse me. And then the upper Rio Grande did see a number of these storms later on the year that did help out a little bit, but snowpack did peak below the 10th percentile in that basin. And I'm going to draw attention to three individual sites within the upper Rio Grande Basin, mainly because I just wanted to show what some of the snowpack, just how the snowpack behaved down in that portion of the state this year. Really quickly, you can see last year, 2024, and median. Here we're looking at Medno Pass, which sits in the Sangre de Cristos, right on the eastern border of Great Sand Dunes National Park. This site does have a tendency in some of the lower years to be more of a transient snowpack, which means a snowpack that really isn't seasonal, kind of comes and goes. In this year, it wasn't really transient, but we really didn't get that much snow. We didn't get anywhere near close to the peak, not even 50% of the typical snowpack peak did we see. And we also saw that it melted out early. One of the earlier years, we saw that melt out. Moving on to the western side of the basin, the upper San Juan Snowtell, which actually sits in the actual San Juan Basin, but is not very far from the Continental Divide. Here again, you can see that the snowpack was very close to the minimum historical snowpack experience there. It was a seasonal snowpack. It did accumulate and persist over the course of the year, but it was not very much snowpack and close to the minimum there. So those two sites that I previously mentioned are indicative of what we were seeing at some of the sites, but they're definitely not the norm in the upper Rio Grande Basin. I think Middle Creek was a little bit more the norm as the trend of snowpack over the course of the year. Again, we did have a solid seasonal snowpack here, was a little more than 50% of the median, but was still well below normal and in that 10th percentile range. So a pretty low snowpack in the upper Rio Grande Basin, unfortunately. Okay, so zooming out and away from the upper Rio Grande Basin, but looking at the Arkansas River Basin here. Again, snowpack in the Arkansas 2 as an average only wound up being in the 10th percentile. We did receive a number of storms in the early spring months that did help out a lot. We did see a nice 2-inch average boost in snowpack and precipitation at the snowtell sites in the mountains of Colorado. I think we saw a few sites that had a little bit more, as Ali mentioned, but it was a helpful storm. But in terms of snowpack peak, we were barely 50% of the normal snowpack peak in the Arkansas. All right, having a look at precipitation. The whole state of Colorado is at 87% of median today. And it most closely compares to about 2022. Hopefully that sits relatively fresh in our minds. Also wanted to look at it from the standpoint of a map. Statewide precipitation is 87% of median. This was back on the 16th. Excuse me one second. Forgive me, tickle in the throat there. Precipitation across the state in year to date has been better, slightly better at least in the eastern mountains, and not as good in the western mountains. And then zooming in, or I should say higher resolution, looking at some of those sub-basins across the state, you can see that we have a number of basins that are a bit closer to normal, but for the most part still a bit below across many of the mountain basins. May precipitation has been bit better, but of course has been kind of localized. Fortunately, it's come to a number of the basins that have needed it: the Rio Grande, the combined San Miguel, Dolores, Animas, San Juan, and the Arkansas River Basin. But the Colorado headwaters, which is here, and the Yampa and White have really not seen as much of that precipitation so far. Fortunately, though, the half-inch of precipitation that we received over the last 5 days did seem to target the Yampa, White, the Colorado, and the Gunnison River basins, as I recall correctly. So a little bit of boost there. But when April, as Ali pointed out, is one of your bigger months of precipitation, you need a lot to make a significant difference. And we really haven't seen that. As much as we would like to in those northwestern basins. So I just wanted to go back just a little bit, a few days, as I mentioned a little bit earlier, or I think Ali kind of mentioned it, that storm from May 4th through about May 8th provided about an inch of precip across the majority of our SNOTEL sites. We went from 84% of median statewide year-to-date precipitation to 88% of median. So a 4% increase over 4 or 5 days wasn't much of an improvement, but we'll take what we can get. Wanted to highlight just a few of the major basins in the state: San Miguel, Dolores, Animas, San Juan, just flirting with that 10th percentile, still running pretty low for year-to-date precipitation, and then highlighting the improvements that we did see in the Arkansas River Basin in terms of precipitation. Saw a pretty good boost from that storm on the 4th through the 8th. Quick view of soil moisture. The mountains are indicating, not surprisingly, an improvement in soil moisture at the 8-inch sensor with snowpack melting and in full swing right now. We're going to see the soil moisture improve, particularly at that 8-inch sensor. You can see it's happening across pretty much the majority of the sites that we have those sensors at. And then the 20-inch sensor is showing improvement in most basins. I'm not exactly sure why it's not quite showing up in those southern basins. I wonder if maybe we just really don't have that much moisture. I haven't had a chance to really dive into the sensors and to see how those 20 or 40-inch sensors are responding. But I think we did see in some of those graphics from Ali that they were running a bit low, if I recall correctly. But elsewhere, looking at pretty good soil moisture. All right, two slides on reservoirs. Reservoir storage statewide is 92% of median, near normal in just about all of the basins with the exception of the combined San Miguel, Dolores, Animas, San Juan basin. Not exactly sure why it's below normal there, but just showing that information. And then just wanted to show a time series of where reservoir storage has been and is now. So the state of Colorado is in orange here, and you can see that over the last 2 months, we've seen a 2% decline. Over the last month, we saw a 1% decline in total reservoir storage across the state. And then I wanted to just draw a little bit of attention to that San Miguel, Dolores, Animas, San Juan basins where we've seen a little bit more decline there over the last 2 months or two. So hopefully we'll see a little bit of an improvement there. Otherwise, elsewhere, reservoir storage is pretty close to normal, thankfully, a little bit below. And hopefully with runoff pretty much in full swing at this point, we'll see those reservoirs get to capacity. Stream flow forecast, taking a step or 2 steps back, going to March 1, you can see that the majority of the state was expecting stream flow forecasts to be near normal, at least in the northern and eastern portions of the state, not so much in the southwestern. But unfortunately, as we've been highlighting over these presentations, snowpack has just been melting out a little bit too quickly, and precipitation has not been measuring up across the majority of the state. And so we've seen a decline across all basins over the last 2 months. This is where May 1 stream flow forecasts were set to be at the beginning of this month. And then we'll have our final monthly forecasts put out here on the 5th working day of June. So we've got a few more days, 2 weeks before that. But the data will be based on June 1 data. And based on what we're seeing right now and future weather predictions, it looks like those stream flow forecasts will probably continue to decline. Although we'll have to see how this monthly precipitation through May in some of those eastern basins has really played out, and how it will end up by the end of May. But I would bet that it might not make too much of an impact, seeing as how quickly snowpack has fallen. Just wanted to draw a quick attention to the spread of, or kind of the histogram of stream flow forecasts. So on the left, we've got the San Miguel, Dolores, Santa, San Juan basins, and on the right is the South Platte Basin. These are the individual forecast points for which we predict flow forecast based on the information that we gather. These two graphics are from 2 months ago, again, going back to March. I just wanted to simply draw out that the gray line is normal runoff in both of the graphics. You can see that on the left graphic, the San Juan Basin forecast were predicted to be largely below normal. And in the South Platte Basin, we were looking at forecast near normal on March 1. And then fast forward to the most recent May 1 forecasts, nearly all runoff scenario outcomes for the combined San Miguel, Dolores, Santa, San Juan forecast are below normal. Even if we got a considerable amount of precipitation, we would not reasonably expect any of the runoff scenarios to get near normal. And in this case, I don't have, the gray line is not showing up simply because it's covered by the right bound of this table, of this graph. And then looking at the South Platte River Basin, the gray line does appear here. Here's near normal, but you can see that those forecasts have shifted significantly to the drier side. So feel free to have a look at the other basins. We produce the forecasts and these graphics for all other basins across the state. I just did not highlight them there. I just wanted to show some of the more extreme major basins in the state. Okay, so these are the last series of graphs that I have. I usually like to show these snow to flow plots in the spring to compare similar years, snowpacks, and their runoffs and the hydrographs. Forgive me, these graphs are a little bit complicated, but I do think they're pretty effective in demonstrating where this year and a similar year's snowpack and the corresponding runoff and the runoff that we could expect this year. So again, sorry, it's a little bit complicated. I tried to just use the orange line, which is last year's snowpack and runoff, and then a similar year, which the color of that line varies, and then this year's snowpack, which is indicated by the solid black line, and this year's runoff to date as the black dotted line. So here in, and I have to, of course, select pour points that are our stream flow forecast points. In this case, it's the Rio Grande near Del Norte. And then the corresponding SNOTEL sites that are most often used in those forecasts. So you can see in this case, the snowpack in the Rio Grande River Basin above Del Norte is largely depleted. There is still some snow there. But for the most part, it's more than 50% melted off. We have seen that we do see here that the stream flows have responded and are increasing. But based on the similar year, which I selected as 2013, it seems like there could be maybe another week or two of stream flow increase, and then we will probably wind up seeing a decline. One thing to point out here is that we had a higher snowpack peak in 2013, and the snowpack held on a little bit longer, at least to this point. So I would expect that our 2025 hydrograph here will probably start to round off or peak out here relatively soon. Moving further north into the Colorado River near Dot Cerro, snowpack is not quite 50% melted out here. We've got a ways to go, and the hydrograph has really not responded. This is very normal. most closely compares to about 2022. Snowpack held on a little bit longer in 2022, but did not peak out as high as we did this year. So I'm anticipating that this hydrograph will continue to increase for at least another few weeks. And we can continue to watch that through our SNOTEL sites. Looking at the Gunnison River near Gunnison, snowpack here is mostly depleted at our SNOTELs. And the hydrograph is responding. It's coming up, but it looks like we have a ways to go before the hydrograph tends to peak. And in this graph, I picked 2021. Peak was relatively similar, and the melt out seems to be happening not quite, or it seems to be happening a bit faster than it did in 2021. So, but we've got a ways to go with that hydrograph there. In the San Juan River, snowpack is largely depleted there. Using the 2018 hydrograph, which was a little bit higher but melted out a little bit faster, it looks like the hydrograph there has probably gotten close to its peak, but again, something to keep an eye on. Arkansas River at Salida, snowpack is still coming down. We did get a boost from those storms the last 5 days, and I would anticipate the hydrograph is going to continue to rise there. All right, so in summary, snowpack as of this morning is 58% of median. That's down from 70% on April 22nd. The highest snowpack in the state is at 72% of median, and that value is as of Thursday. And then the lowest snowpack in the state is 13% of median in the Rio Grande. Year-to-date precipitation is 87% of median. That's down from 90% of median last month. Reservoir storage is at 92% of median, down 1 percentage point from last month, lowest in the San Miguel, Dolores, San Juan basins. And then stream flow forecasts are projected to be below normal, and we'll just have to see what winds up happening for the June 1 forecasts. That's all that I have.
Thanks, Brian. Great presentation, but not great news. Yeah, it's interesting, the fact that stream is, started so much earlier this year. I think you said, was it 11 days on average?
The snowpack peak occurred
Snowpack
11,
peak. Yeah.
11
Okay.
days earlier than normal.
Gotcha. Okay.
But I haven't really tracked when how much earlier the hydrograph has started to rise.
Gotcha. Well, thanks again for your presentation. Any questions for Brian? All right. I don't think there are any. Thank you again, Brian.
Yep.
And we will have Jeff Deems conclude our presentation series today. Jeff Deems is with the Airborne Snow Observatories, and he will give us a look at this year's snow measurement program in Colorado. So I will pass it over to Jeff.
Great, thanks, Emily.
Yeah.
Hopefully you can all hear me okay. I'm outside in a lovely day in Montana, but it's a little chilly. Yeah, thanks for the invite here, and happy to build on the prior two great talks and give you a sense of what we're seeing through Airborne Snow Observatories and Colorado Airborne Snow Measurement Program so far this year. The quick background on the program, basically, as we all are aware here, the mountain snowpack is our biggest reservoir, governing really the entire year of stream flow and water availability. But it's a pretty complicated thing, that snowpack, and it's the distribution of where the water is and how it evolves through the season across the mountains is highly complex. As we just heard from Brian, our typical means of monitoring that are through, again, our CS SNOTEL network that has a pretty good distribution around the state and lots of different, or all the river basins. what we're trying to capture with that network is really an index of what the basin water equivalent is doing and how it evolves through time and how that can be related to summertime stream flows. However, we can't put those stations everywhere, and we can have significant evolutions of the snowpack in other parts of the basin that may or may not be related to what the snowtails see. So really what we need in order to help avoid some of the potential surprise by what the snowpack is doing outside the snowtail network is to build on that time series with some full watershed measurements of the snowpack. And trying to capture the pattern that you can see in the background here in this image, looking southward into the Upper East River back in 2019. So the way this can play out, and I'll highlight an example here to show some of the changes that can happen within the watershed that really demand both the continuous in time measurement from the snowtails, as well as the continuous in space measurements that the ASO program can provide. So here's an example from the past 2 years, so 2024 and 2023. This is for the East River in the Upper Gunnison, but interesting examples like this could be pulled out for pretty much any basin in the state. So last year, quite a bit lower snowpack in 2024 than there was in 2023 in most of Colorado. Although the snow stations in the East River, Butte and Schofield Pass snowtails were still showing a peak above median, although perhaps a bit early in 2024. So we're expecting a lower snowpack. If we look at the comparison of basin-wide snow water equivalent measured by the ASO program in early April in both years, that is indeed the pattern we see. All of those brown colors on the map are showing that there's even greater than a half meter in some cases of water equivalent difference from 2023 to 2024. However, the spatial pattern is pretty interesting. Those really big differences are in the west part of the basin in the Ruby Range, whereas in the eastern part of the basin, the light tan to even white colors are indicating that there's really not much difference between the 2 years over there in Cement and Brush Creeks. And while we can see a little bit of that pattern just looking at the two snowtails, it really those two stations alone can't really give us that full picture. As we move into looking at the May flights, so again, difference between late May 2024 and late May 2023, that east-west pattern persists. It's gotten a bit more muted, but it's actually flipped sign over in the eastern part of the basin where 2024 actually has more snow than in 2023. That can be important, not just in how it adds up to the basin-wide snow water equivalent total, but also how water is available at the sub-basin scale for diversions or applications and rights administration within the watershed, depending on whether individual rights have sources in Brush or Cement Creek or over on the Slate River sides of things. So really, the combination of these two techniques of continuous in time measurements from the snowtail network and continuous across the landscape measurements from the ASO airborne snow surveys and integrated modeling really helps give us that multidimensional, maybe 4D picture of our important snowpack water resource. So that's the motivation behind the ASO program. We started as a NASA program back in 2013, and over many years of or 8 years of evolving proof of concept and building the operational capacity and applications in concert with a lot of Colorado stakeholders and the state and research entities. We about 5 years ago emerged as a Colorado Public Benefit Corporation as ASO Inc. Doing the same thing we started doing at JPL, which is to map snow water equivalent, snow depth, and snow albedo at high resolution and high accuracy across entire watersheds. We couple these unique measurements with physically based models of the snowpack and the hydrology to allow continuous tracking of that snowpack evolution and snowmelt runoff and hydrologic forecasts that are constrained by those snow observations. All of this is geared towards decision support in producing not just high accuracy products, but producing them quickly so that they're available at very low temporal latencies. The Colorado Airborne Snow Measurement Program is a stakeholder-led effort that began in 2020 and involves over 100 participating stakeholders from across Colorado's water community. The objective of the program was to create the foundation for and a pathway for a sustained ASO measurement program within the state. The entities listed here with the logos represent the planning committee that has helped guide and evolve the evolution of this program since 2020. Just this year, I will note the successful passage of House Bill 1115, which implements a new program within the CWCB, the Water Supply Measurement and Forecasting Program, that effectively makes this CASM effort a program within the CWCB. So congratulations to all involved that have made that possible. I think it's a really important step towards adding capacities to our ability to monitor and forecast the evolution of our snowmelt and water supply in Colorado. So the CASM program for this year, we are flying in all of the basins shown in green on this map, and the number of flights are per basin are listed in the table to the right. The red numbers are indicating basins where we are still aiming to collect the final flight for the year. So we've got a bunch of activities ongoing this week. 33 different funding sources across the state have pulled this together this year and helped make this happen, from individual water conservancy districts and river districts to the state projects bill fund and a couple different federal sources as well. So a huge team effort to make this all happen, and it's been a great year, a really unusual year, as you heard from Brian, in terms of how the snowpack has accumulated and evolved, and really great to have this measurement set. I'll run through an example here from the Blue River and Upper South Platte just to show you what some of these data look like, and then take a quick tour around the state to show us some current conditions. So our first flight in the Blue and Upper South Platte this year was on April 10th and 11th. And the water equivalent map for those two basins is shown on the right there, and I've shown all the SNOTEL locations within the two basins there with the red symbols. So we measured 209,000 acre feet of snow water equivalent in the Blue River, the Lake Dillon Basin, and 107,000 acre feet in the Upper South Platte area shown in the outline there. Of course, it being a spatial product, we can divvy that up into whatever subcatchments are of use. We're showing the ones here that were desired by the stakeholders involved, but it is a continuous product that can be divvied up in any number of ways, including by elevation or aspect or any other spatial metric. Looking at that comparison to prior years, so this is this year, April 2025, minus April measurements in 2024 for both basins. We flew a reduced area in the Upper South Platte last year, so that's why there's parts of that basin that aren't shown with any colors in the map. But a pretty interesting difference pattern where there's slightly more total snow in the Lake Dillon watershed this year than last year, 209,000 acre feet compared to 202,000 in mid-April last year. But a lot more snow in the north and lower elevations, and less snow, especially in the Blue River headwaters this year compared to last year. Over in the South Platte side of the divide, mostly much lower this year than last year, with the exception of the Upper North Fork and the Guanella Pass zone out there. You can see there is a bit more snow this year. So kind of interesting evolution there. And one further comparison, this is compared to 2023, so 2 years ago. And 2023 was a fairly big year, snowpack year in most of the state, but it was actually a bit lower in these watersheds compared to this year and the past year. Again, really interesting patterns of difference from the April flights in 2025 compared to 2023. So that's kind of some flavor for the type of things that we can see when we have both the full basin picture and the full time series picture from the SNOTELs. Both of those together can help us constrain our snowpack and hydrology models. And I'll show a few examples from around the state of these graphs. So I'll explain these two plots here real quick, and then show similar ones from elsewhere. So the graphic here is showing the evolution through the season of the SNOTEL mean SWE depth, that's in the orange line, and then the mean depth and also the total SWE volume from the ASO and ASO constrained ice snowbow water snowpack model with the blue line, with the ASO airborne surveys shown with the red diamond there. The blue line you can read on either axis, either an average depth of water equivalent or the total basin water equivalent volume on the right axis. So you can see, and this is the case almost everywhere, that the SNOTEL station mean water equivalent depth is higher than the total basin average. That makes sense. At the total basin, we're measuring both the really deep parts of the watershed as well as those larger areas of lower snow depth and lower SWE at the lower elevation. So the mean snow water equivalent depths are lower, but we can also get a total volume out of that. In this case, also, the peak timing correlation is interesting, where the peak in the SNOTEL SWE it looks right up equivalent with the total basin water volume SWE peak. So that's good to see that those stations are representing that temporal evolution of the full basin water this year. Another way to look at the spatial data is SWE depth and volume by elevation. So the left panel here is the average water equivalent depth, similar to what the SNOTEL stations measure at those locations, but this is throughout the watershed. The dark line in the middle there is that average snow water equivalent depth at each elevation band, and then the shaded area is plus and minus 1 standard deviation, so the variation of SWE depths at each elevation band. And you can see that generally we have deeper snow at higher elevations, not unexpected. And as we move across to the right-hand plot, that's the total SWE volume by elevation. And the reason those are different is because there's different amounts of land area at different elevations, and that's shown in the middle there. So in effect, if you multiply the first plot by the second plot, you get the third one. So depth at each elevation times the amount of land area at each elevation gives us that volume perspective. So even though we've got our deepest depths, going all the way up to 14,000 feet plus in the Blue River Basin, there really isn't much land area up there, and therefore those highest elevations don't represent that much total water equivalent volume. We also have plotted some of the SNOTELs on the depth plot, and we can see that in this case, and we don't have Hoosier Pass on here, but that's on the next plot, that the SNOTELs are outside 1 standard deviation of the depth distribution at those elevations. Now, that's not necessarily a bad thing. Don't want to imply that. The SNOTELs tend to be located in deeper snow accumulation areas so that they provide data later into the melt season. And again, they are used in an index method to keep track of the snowpack. So where that could become important is if we're trying to use those data to represent water volume or to extrapolate to other parts of the watershed, then it's important to know how they represent or not, or how they relate to the depth distribution throughout the watershed. Okay, so that's the Blue River, and I'll step through a number of basins around the state because I showed the South Platte. Here's that evolution as well. Again, similar peak timing, although I'll note we've been bouncing around at peak volume since about late February in the South Platte, kind of up and down a little bit with the various storms. And we're still showing about 53,000 acre feet of snow left in the watershed there. And the elevation distribution kind of similar to across the hill in the blue in terms of where the snow tails are in the distribution. And that we really see a peak in volume around about 12,000 feet. Moving southward into the Rio Grande, it looks like our volume peaked back in mid-March, even though a lot of the snow stations continued to accumulate and remain at high values into mid-April. About now, a lot of the snow stations, snowtail stations in the Rio Grande have melted out. There's just a couple contributing to that average, but you can see we still have 136,000 acre feet of snow in the basin. That was measured with an airborne survey just a few days ago. Here's the elevation distribution. In this case, the snowtails are pretty well in the current band of the standard deviation. Again, this is from May 18th. And as we go forward and build more of these plots over time, it'll be interesting to track how those stations and the elevation distribution evolve over the course of the season. Over in the Dolores, again, a SWE volume peak in mid-March, snowtail peak around the same time, maybe a little bit later. And things melting quickly in the Dolores, still showing about 25,000 acre feet of snow in the models down there. Most of that snowtail site index comes from the Black Mesa snowtail site. You can see here, everything else is I think melted out. At Black Mesa being high elevation and also kind of high biased in terms of water equivalent is keeping that snowtail average higher. Into the Taylor River. I'm sorry, I don't have time to go into every basin that we're flying in the state. I'm trying to bounce around and give a bit of flavor. So we are actually in the air to fly the Easton Taylor right now for our second survey. First one was on April 7th. And as you can see in the Taylor, the snowtails have melted out. We're still showing, the model's still showing about 23,000 acre feet of SWE above Taylor Park Reservoir. And we'll get an update on that in the next few days from that recent survey. And then northward into the Yampa and Elk basins, treating those together here, 209,000 acre feet total left in those, according to the models. And again, most of that snowtail index is coming from the Tower snowtail, which is one of the higher SWE accumulations in the state reliably. But a lot of the other stations have melted out already in the Yampa. Okay, so the iSnowbow model that we run, that our M3Works partners run, constrained by the ASO flight data, allows us to continually track the evolution of not just the basin water equivalent, like is shown in this table, but also lots of other components of the snowpack, like cold content and other snow components. So this table is showing our current model state, or as of a couple days ago. We will be updating a number of these basins with flights hopefully this week. The spring weather has been super challenging to accommodate flights recently. But again, as I mentioned, our team's in the air right now over the Easton Taylor and aiming to get Roaring Fork, South Platte, and Blue River, Yampa and Elk, and Colorado headwaters at Windy Gap notionally by Sunday. We'll see, but aiming to get all of those as soon as possible. We also work with the Colorado Basin River Forecast Center to get our data into their model, both in experimental forecasts, and just this year they've started nudging some of their operational forecasts using ASO data. And then we also run the WRF Hydro model internally to provide April through July runoff forecasts as well. And this is a brief summary of some of those forecasts. To date, we forecast for over 200 forecast points throughout the state in all of those watersheds that we're flying. So that's probably a whole hour to discuss all of that stuff. But basically at all of those points, we're providing weekly ensemble streamflow prediction forecast updates. Every time we ingest a flight survey, we produce a detailed report showing lots of different components of the snow and water balance in the model. That allows us to dig into different components of how the snow and water and the forecast are evolving. I'll note that in general, our WRF hydro forecasts have been mostly higher than the federal forecasts this year, especially in the southern basins. We've dug into that a bit, and it seems that those forecasted volumes are consistent with the amount of snow we're still seeing up there. And we'll see how the latest round of surveys coming in this week will influence those, but those forecasts have largely been consistent throughout the melt season. And as I mentioned, somewhat optimistic compared to what the RFCs and NRCS forecasts are showing. We'll see how that evolves. As Brian, I think, showed really well, the runoff is just starting to increase. We're just sort of at runoff onset in a lot of basins. And some of that timing of runoff increase seems to be about our typical timing for that. So plenty of runoff yet to come. I'll note some ongoing areas of refinement with this system that is very much collaborative with engaged stakeholders in each watershed, is trying to get time series of managed flow data. We're producing full natural flow forecasts, so we want to make sure that we're including any management effects on observed stream flow. Working to improve soil and groundwater calibrations and also precipitation inputs in mountain watersheds is always a challenge. So we're continually refining that. So and snapshot from just a few minutes ago of our plane in the air over the East River. Keep your eyes open for data forthcoming there. All right, just to wrap up, the ASO surveys and the integrated modeling really adds important dimensions to our ability to monitor our snow water resource. This year in particular, I didn't get into the snowpack temperatures, but we've had very warm snowpacks all year long, which means there's not a whole lot of melt buffer when it comes time to start melting. So that combined with mild spring weather have really accelerated snow melt. We're seeing the runoff increasing, but we're also seeing that there's still a good bit of snow in most basins left to come off. And we shall be wrapping up our surveys this week and continuing our modeling and forecasting throughout the rest of the melt season. Please feel free to reach out to me at the email address there below, or see our website or the CHASM website at coloradosnow.org for more information. Thank you.
Thank you so much, Jeff. Are the flow forecasts that you mentioned updated on the ASO or CHASM website?
Yes, there are.
Okay.
The reports are hosted in both places, and then we've been emailing out the forecast updates and can arrange to, if anybody is not on our distribution email list, please reach out to me and we can get you on there.
Awesome. Questions for Jeff? All right. Jeff, would you mind putting your, oh, I see your emails at the bottom of the screen here. So if anybody has follow-up questions, feel free to reach out to him. Thank you so much for hopping on today and providing that update. And I'm looking forward to seeing how the flights go for the rest of this week. All right. We have a question in the chat from Swithin. I'll just read it aloud to the group. Are there any wildfire impacts across the southern half of the state that we should be calling attention to? Obviously, fire risk will be higher, at least for June, if not the rest of the year, depending on precipitation received. That's kind of a question to the whole group. Any thoughts on Swithin's question, or Swithin, if you want to add more context to your question, feel free.
So just kind of going back to previous incarnation of this group, the Water Availability Task Force, this is kind of something we did when we saw dry springs developing, and obviously in the groups, there's plenty of people who will bring up concerns for agriculture, for municipalities, fire risk we got addressed last meeting. Something that doesn't have a voice is impacts to the environment, the wildlife, whether that's stream flows, stream temperatures, survival of the young, and I'm just wondering, is that something we might want to look into if we don't have somebody on the call today? You know, how dry it has been for the entire season, basically across the southern half, maybe up at the western border of the state. Is there things that we should be raising attention for to kick up the proverbial ladder chain of command, to get things looked at before it's crises? And I don't know, I'm just throwing it out there, just trying to indoctrinate some and remind others that, yeah, this is what we used to do. Don't know if that's still what we're set up to do, but trying to lend the experience.
Yeah, I appreciate that. And you're right, we do have people on the call who are, you know, concerned with municipal water, ag water. But yeah, I can look for potential, you know, guest speakers, or if this is just something that we want to put on you know, our agenda for upcoming meetings to discuss further as a group. I'm absolutely open to that. I don't have an answer to the question,
Right.
but
No, I didn't
yeah,
expect an answer. I was just,
yeah.
but we do have a good selection of people on board. I saw at least one from CPW. I'm assuming she's from the Northeast division or district, whatever, but seems to me that there probably would be some impact so far. Of course, it might rain and turn everything around, but thought I would bring the topic up.
Yeah, thank you for doing that. Always appreciate input and suggestions from the group, so it's very appreciated. All right, well, it looks like our CPW folks are not on the call, just looking at the participant list. So I will end our call today. Thank you all for hanging on for the 3 presentations. Our next WCMC meeting will be June 17th. So I will see you all then. Thank you.